Hey everybody! In this episode of Better Data, Better Results, we're going to look at industrial chemical management. Specifically, we want to talk about chemical injection variance. First, let's just start by asking, what is injection variance? Industrial operations managers inject specialty chemicals to improve operational processes and prevent failures. Specialty chemicals and additives can do things like prevent corrosion, minimize wear, remove harmful byproducts, and enhance production quality. In most cases, the rate at which we inject chemicals is directly linked to certain parameters of an industrial process. In a simple example, let's say we wanted to inject scale inhibitor into a water pipeline. We usually want to inject that scale inhibitor proportionally to the water flow rate. We measure this in terms of parts per million, or ppm. For instance, if I wanted to inject 10 parts per million, or 10 ppm, of scale inhibitor into a water pipeline flowing 500,000 gallons per day, I would want to inject 5 gallons per day of chemical. Based on operational parameters, sometimes chemical injections don't actually hit this target. This is what we call variance, the difference between the target injection rate and the actual injection rate. To avoid variance, we want to change our pump set points to match our target rates whenever those targets change. This is where things get challenging. Usually, pump set points are changed manually when a technician physically interacts with the pump to make updates. Let's say the technician makes the rounds once a month to get this done. The problem with this? Industrial processes are highly variable, and the rate at which this pipeline moves water might vary between 0 gallons per day and its max throughput depending on the processes which feed into the line. Because these industrial processes can change every second or faster, and chemical injection set points change only weekly, monthly, or worse, this introduces a lot of variance. In fact, WellAware baseline data collected from thousands of chemical injection sites suggests that 3/4 of pumps miss targets by over 25%. Why is that bad? Well, under-injection is bad because it doesn't protect our asset. If this chemical is designed to do something to improve outcomes or prevent failure, not injecting enough usually means we see poor outcomes or failures. If we inject too much, we're both wasting money on unnecessary chemicals and potentially introducing downstream challenges where we need to remove excess chemicals or their byproducts. Bottom line, missing our targets means more costs. Cost for maintenance, cost for repairs, cost for downtime, and potentially cost to human health. Fortunately, we can solve this problem. I want to show you how we can automate chemical injection rates and shrink variance to zero using WellAware On Demand Chemical. So what we're looking at here is the WellAware On Demand Chemical platform. Specifically, we're looking at water flow rate, which is measured by this blue line, on a pipeline where we're injecting a scale inhibitor. So we can see that this water flow rate is fluctuating between about 500,000 gallons per day down to 0 gallons per day, up to nearly 1,000,000 gallons per day. These moments of zero injection are important. Clearly the pipeline has been shut off for some reason. Maybe that was planned or unplanned maintenance, or we had some incidents upstream. Obviously when water's not flowing, we wouldn't want to inject chemical. So from this water flow rate curve, we actually get a recommended rate. So remember, we want to inject at 10 parts per million, and that's not changing throughout this scenario. So let's look at the recommended rate. The recommended rate curve is going to match that water flow rate curve. So generally at 10 parts per million, we're going to want to inject between 5 gallons per day down to 0 gallons per day when the water is not flowing, up to between 8 and 9 gallons per day. So this is our target. So let's look at what is actually happening. First, we'll look at the injection rate set point. Now this orange line represents the pump injection rate set point. It's what our technician in the field has set the pump to inject to. And we can see that that technician is generally updating the set point once per month to hit the recommended rate. So every month when it's updated, we see that it intersects the recommended rate. The problem with this is we have all these scenarios where the set point does not match the recommended rate. And we could see some very critical scenarios. First of all, when the recommended rate is 0 because the water is not flowing, the pump is still injecting. That's tremendously wasteful and it results in a lot of overspending on chemical. The opposite scenario here is true, where the pump injection rate is actually changed when there's no flow, but then the flow returns and the pump injection rate is not changing. So we actually see that while water is flowing through the system and there is a recommended rate, we're not injecting any chemical. This is a problem that we need to address. And we actually can see this in terms of the total variance. So let's look at both the variance in terms of volume, represented by this purple line. We can see that we're missing targets by anywhere between -5 and 5 gallons or 7 gallons per day. So we're either under injecting by down to 5, 6 gallons per day, or we're over injecting by up to 7 gallons per day. This is a problem, and we can actually see this in the actual parts per million versus the recommended. So remember, we're trying to hit 10 parts per million, but we can see on the green line, the actual parts per million misses the target wildly. So what we're going to do is we'll show you how we would fix that by applying injection automation to this particular location using the WellAware Field app. So now I'll show you how we use the WellAware Field app to connect to a device in the field and update the pump injection settings. So let's get started. So the first thing I need to do is select the company that I work for. And the reason I do that is all of the Connect devices are secured according to the company they belong to. So let's select WellAware. And now if I scan with my phone, I'll see every WellAware Connect or Sense device that is within Bluetooth range. In this case, because I'm on location, I just see my one device. So let's click into that device and update it to use chemical injection automation. All right, we are now connected to the device. As you'll notice, I've got many applications that have been loaded onto this Connect device, but in this case, I want to look specifically at the pump application. So let's click pump, and we'll see right now I'm running in set point mode with a max pump output of 20 gallons per day. The pump is currently off, and I want to change it to injection automation, and in this case, a particular kind we call proportional dosing. So I'll go to Advanced Settings, change pump mode, and select proportional dosing. Now that I've done this, I can configure the proportional dosing so that my target is 10 parts per million, and then my low and high flow based on the input that I'm receiving. So in this case, this meter is capable of 0 to 1 million gallons per day, and then a fail-safe flow. This is important. If I lose signal to the automation, I want to make sure that I'm injecting some minimum amount of chemical. So in this case, we'll assume that on average, if I lose that connection, we're flowing at 500,000 gallons per day. I click save, I set dosage, and now my pump is operating in that mode, taking a reading and updating the meter flow rate in real time. So now that we've made that change with the WellAware Field app, let's look at the results. So we can see here on August 1st, we upgraded to injection automation using the WellAware Field app. We changed from a regular pump injection set point, changed manually, to injection automation by monitoring the water flow rate and updating that injection rate set point 6 times per minute. And here's the result. At first, our injection rate set point changed once per month. But then, after the change, we see that it matches the recommended rate almost perfectly. And we see the same thing in the observed injection rate. Whereas before it was only updating once per month, now it is almost perfectly matching the recommended rate. And why is this important? Well, again, we're trying to treat at 10 parts per million. So let's look at the target versus the actual treatment rate in this scenario. So if we look at the recommended parts per million, it's 10 parts per million through this whole period. Now let's look at the actual. If we zoom in a little bit, we can see this more clearly. After we made the change to injection automation, we are almost perfectly delivering the amount of chemical that we need to deliver at the right time, 10 parts per million based on that water flow rate. And this is important because it means we're spending less on chemical when we don't need to, and we're providing better protection for our asset. And that is why we use WellAware On Demand Chemical to provide injection automation.